In this video, we are going to look at a problem on inclined planes, how to calculate the work done for an object which is placed on an inclined plane. So we have got a 10 kg block. It's released from rest at the top of an inclined plane of height 2 meter as shown in the figure below. So let's just write down that information. The mass is 10 kg. That means the force of gravity will be 10 multiplied by 9.8, which is 98 Newton. The height is given to us as 2 meters. So I'm just going to write it on the diagram itself. So height is equal to 2 meter. The coefficient of kinetic friction between the block and the surface of the incline is 0.2 Newton. So we have been given what is the friction on the surface. Let's just write that. Mu, coefficient of friction, is given, which is 0.2. It's asking us to calculate what is the work done by gravity, then work done by friction, and work done by normal force. So first thing, we have to draw our forces on this block on the diagram. So let's just focus on the object and let's draw all the forces. So the force of gravity is going to act vertically downwards, which is Fg. Then normal force is going to be perpendicular to this surface. So this is the surface on which the block is kept. We need to draw a normal force perpendicular to this surface, which will look like this. That's Fn. And we know that the box is sliding down. So the friction should be opposite to its motion. So we'll draw the friction upwards. That's the direction of friction. Now the first question is asking us, what is the work done by gravity? So gravity, we can see that this is the force of gravity and we want to find out what's the work. So let's write down what is the formula for work. So work is equal to force multiplied by displacement in the direction of force. So this is important, displacement in the direction of force. So we have got gravity acting vertically downwards. So as the block is moving down, what is the displacement of the object in the direction of the gravity? So if you look at the diagram, as the block moves down, in the vertical direction, it covers a displacement of 2 meters. So this 2 meter is in the direction of Fg. So work done will be equal to force of gravity. So let's write force of gravity multiplied by the displacement in the direction of gravity, which in this case is the height. Now force of gravity is 98 Newton, which we calculated before. So 98 multiplied by 2, that's the height. So that's 196 joules. Next, we want to find what's the work done by friction. So let's again focus on the diagram. Okay, let's focus on the diagram. We are going to figure out what is the displacement in the direction of friction, because in the second part we are trying to find what's the work done by friction. We can see friction is along the surface. So you can see friction is acting upwards along the surface and the box is sliding downwards. So this displacement is along the same line as that of the friction, that is, it's on the surface. So we will be writing BA as the displacement. So we'll write work done. Work is equal to friction multiplied by the displacement in the direction of friction, which in this case is BA. Okay, and we can also write this work as negative. We will be writing it as negative work because friction always does negative work. Friction is always opposite to the movement of the object. So we'll write it as negative. Okay, now we want to find what's friction and what's BA. That's what we are going to do. Now for finding BA, we are going to take this triangle. So in triangle ABC, we are going to apply SOHCAHTOA or trigonometry. So sine theta is equal to opposite over hypotenuse. So theta in this case is 30, sine 30 equal opposite is 2 meter, opposite to the angle. So we'll write 2 over hypotenuse, for us it's AB. So we are going to write that as AB. So this, if you calculate, you will get AB, or that is BA, is equal to 4 meter. So that's our displacement. Okay. Now we want to find what's the friction. So to find the friction, we are going to use the formula for friction. We know that friction is mu Fn. So let's write that. Friction is equal to mu Fn. To get Fn, we need to go back to the diagram and do the components for the gravity. Because Fn, right now we don't see what's opposite to Fn. So that will be the component of the gravity. So we'll do the components of gravity. Let's show the components. This is one component of gravity, which will be Fg sine 30, and this will be the other component, which will be Fg cosine 30. Always remember, the component which is perpendicular to the surface will always have cosine, and the one which is along the surface will always have sine. Okay, because the angle is given to us, this is the angle which is given to us. So always the component which is perpendicular will be having cosine, and the one which is parallel, the component of the gravity which is parallel to the surface, will always have sine. Now we can see that Fn is opposite to Fg cosine 30. So we'll write that mu Fg cosine 30, and we'll substitute the numbers. Mu is 0.2. Fg we already calculated, which is 98 times cosine 30. Let's just get this value. 0.2 multiplied by 98 multiplied by cosine 30. That gives us 16.97 Newton. So that's friction. We have got the value for friction, we have got the value for displacement. We'll put it back into our equation. So negative, because work done by friction is always negative. Friction value is 16.97 multiplied by 4. So that will be, 16.97 multiplied by 4. That comes out as 67.88, and we can put the unit as joules. So that's how we find the work done by friction. Next is work done by normal force. So let's write down. Work done by normal force should be normal force multiplied by displacement in the direction of normal force. Now let's go back to the diagram. This is how normal force is acting. Do we have any displacement in this direction? Is the object moving up or down? If your answer is no, which should be no, because we know that the box is moving along the surface, it's not moving up or down, that means the displacement along the direction of normal force is equal to 0. So if I write normal force multiplied by 0, why 0? Because the object is not moving in the direction of the normal force, it's not moving perpendicular to the surface. So our work done by normal force will be equal to 0.